Good morning, it's Jeremy. It's May the 29th, Thursday, and today I'm going to try and receive the CubeSat Veronika, and I'm just looking at my setup here. Over the past couple of videos I've discovered that my V-dipole doesn't have enough gain to get a decodable signal off a CubeSat, so I'm repurposing my ATSC UHF Yagi, which normally points, right now it's pointing east, but normally it's on a rotatable wooden pole here. Normally it points south to the CN tower where I pick up the UHF TV stations, but there's my setup. I've got a bandpass filter and an LNA and the RTL version 5. I found the best setup for me is looking east. So when I look east, there's sort of a jungle of steel condos, but from about 25 degrees up to about 50 degrees where the concrete ceiling comes in, I've got a fairly good reception area. And the CubeSat today is making a pass around 1250, and it's going to be around, I think it's 75 degrees. It might be a little bit high. Yesterday I managed to decode a signal from Veronika. It was only like 20 degrees elevation, but it's much closer today. So we'll see what happens.
So basically, the first thing I do is I check with the N2YO database, and it shows me for Veronika, I've got a good pass to the east, starting around, let's say 1250. Elevation is going to be about 74 degrees maximum elevation. So that should give me a strong signal. Yesterday, May the 28th, there was a pass, but I think the elevation was only around 20 degrees or so, but I still got a signal and I was able to decode it. In the SatNOG's database, incidentally, that's the NORAD number. When you're using N2YO, you have to use the NORAD number because it doesn't seem to know Veronika, the name, but it does know the NORAD number. So there are the passes. You can see the map. The good thing about the SatNOG's database is it tells you the transmitters. So we're at 436.68. There's a GFSK signal. There's also a CW signal. These green icons here indicate the satellite is active. This red icon here, I think, means it's not active. And you can check the data to see if actually people are receiving the satellite, and you can see that they are. And over here on SDR Sharp, as I've explained before, I've set the receive frequency at 20 kilohertz below the 680.680 is where it's going to be received, but I set it 20 kilohertz below. Because of Doppler shift, the frequency will move up and down, and what we can do is we can detect the received pulses, and then with GNURadio you can set the baseband down converter, the frequency translating filter. When I also use gpredict, so when Veronika comes, when the footprint hits my location, the minute that happens, what I do is I hit the record button on the baseband recorder. The files get pretty big. I've got a low sampling rate here of 250 kilosamples per second, so the files don't get too big. After about 5 minutes, what I do is I find out where the signal is, where the signal pulses are, and then I open the file in Audacity and I cut it down to just those areas where there is a signal. So, and about an hour from now, we should be receiving something, and we'll look at it then. So what we're looking at here now is I had about a 5-minute baseband recording, and I cut it down to about a minute and 43 seconds. That's where all the received pulses are. They start around 30 seconds relatively. It's about 3 or 4 pulses. So let's look at that. And then what I do is I move the cursor here where the received IQ was at 660. Right now I've moved the cursor to be in the center of these pulses, so it's up by 29 kilohertz. So that'll be the shift we need in GNURadio, and we'll see that in a minute. So let's just play this and see what the received pulses look like. There's one. There's another. That was a strong one.
there's another one. Okay, so that's it for SDR Sharp. Let's look at the file opened in GNURadio. So there's the file open in GNURadio, and I've got it playing continually. And basically you can see that I think there were about 3 pulses that we received there, and they were strong enough to decode. So it just keeps decoding here. So the first pulse gave a 12 byte PDU. The second one gave an 8 byte PDU, and then we have a 12 byte just repeats itself. So that's what it looks like in GNURadio. The details are in the blog post. I noticed that on my balcony, looking east, the best possible receive location would be between, let's say, 25 degrees and 50 degrees elevation. So on May the 28th, I was down around 23 degrees, and then today I was up around 73 degrees. So not ideal. So the pulses were not that strong. And anyways, we managed to get a decode.